Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is something called a beat crusher, and this is a super simple audio effect that I'm using as an excuse to get into something called JSFX, which is for JSON sound effects, not for JavaScript. We'll get more into this, into what this is, but really, I wanted to get into this because I like producing music and playing, and I really wanted to understand what was going on deep in the effects that I use, things like equalizers and distortion and compression and so on and so forth. And I know nothing about digital signal processing. I know nothing about how computers work with audio. So I wanted to learn more about this, and I'm taking you with me in my journey. And I thought this was something I was going to do in the future because it's complicated to do. It's difficult to code in this domain, and you have to write code in languages that I don't usually use, like C++. But I found recently Reaper, which is a digital audio workstation that I'm also using to edit videos and that I'm also using to produce music. And I am using it to edit podcasts. And I'm also using it to learn about programming for audio or digital signal processing. And it's great because Reaper does it all. It does all these kinds of editings that I was talking about, but it also has its own programming language for programming these JS effects. So yeah, don't get confused with JavaScript. It has nothing to do with JavaScript. It just has JS in the name. But yeah, so let's look into what we are building, and then let's start coding, and we will see all the facilities that come with Reaper for working with JSFX. It actually comes with a whole IDE of sorts for working with these effects, which is cool because it's sort of simple to use, and at the same time, it's super powerful and usually fast enough that you can actually use it in real world stuff. It's not just a toy, but it is not super hard to get into. It's not like C++ and programming VSTs and audio units and proper plugins. And at the same time, if you're running on Windows, you can install these extensions to run your JS effects in any digital audio workstation besides Reaper. I'm on a Mac, so I can only run it in Reaper, but that's fine. Okay, enough preamble. Let's get going. I'm going to record some audio here just to show you what a beat crusher sounds like and what it does. And then we'll get into JSFX and try to build our own. So we are more or less recreating an existing effect. And that's the plan here. I'm going to show you all the JSFX facilities, and then later in other videos, I'm going to try to rebuild some of the most commonly used effects, some of the things you would find in a digital audio workstation usually. Okay, so let's get going. We have a track here. I'm going to, first of all, I guess before I even do any recording and anything, I'm going to just lower the volume on the master channel. And that's because when you're developing plugins and you're working with audio in general, there is a chance that you will mess things up and produce loud noises. And that's something that you always want to do. You want to lower the volume so that if you do something wrong and some loud noise comes through, it won't go through your speakers, or in this case, because I'm recording, it won't come through my headphones, and I won't hurt myself. But at the same rate, I am not wearing my headphones for now as an extra precaution. But yeah, so what we want to do is to lower the volume, not wear the headphones. And when we are certain that we have something that works, we can visually assert that the thing is not going to hurt us, then we can increase the volume and put the headphones on and test this. Of course, for the video that you are watching, you don't have to worry about this, because if some loud noises come through, I will mute them. But if you want to follow along, and I suggest that you do, you can install Reaper and try it for free. And if you want to follow along, then you should follow these precautions. Okay, so let's get into what a beat crusher is. And to do that, I'm going to record some short audio. I'm going to arm this for recording. And now let's record something. Hello world in the world of bit crushers. Okay, so a bit crusher is a distortion effect. It's going to be good for things like maybe guitars and synthesizers, or maybe bass. If you want to get a crunchy bass sound, you might want to distort it. It's a kind of a digital distortion, and it's great for getting started with programming for audio because it's super simple. We are going to write a bit crusher in one line, but we are not going to reproduce every feature that a bit crusher has, but we are going to get the core of the effect in one line of code. And it can also be used for voice. And the reason it can be used for voice is that it can simulate things like recording through a telephone, for instance, where you literally have less bandwidth. So you literally have a bit crusher of sorts. And if you want to try to simulate that with a clean recording, then you can use a bit crusher for that. But okay, so this is what I just recorded. I'm going to put on my headphones and increase the volume because I believe that is safe to do here. Okay, so let's hear this. Hello world in the world of bit crushers. Okay. Hello world. It sounds like this is distorting a lot already, and this is not the intention. It's probably because I have my input too hot. So I'll lower this and try again. Hello world from the world of bit crushers. Okay, so this is better. I can see that it's around 18 dB. So that's a good level to work with. Okay, so I can increase the volume again. Hello world from the world of bit crushers. Okay, so this is not as loud. And by the way, when I'm leveling the audio for YouTube, I am going to put the actual level that we see here. So YouTube is going to compress things and it's going to mess this up, but in theory, you should be getting the same level I'm getting here. And okay, so now we have this sound. Let's bit crush it and hear what that sounds like. So bit reduction. Okay, and we don't want this kind of noise, dithering, and I will not get into that, but we don't want this kind of noise. We just want the bit crusher proper. I'm going to loop this. Hello world from the world of bit crushers. Hello world. Okay. I'm going to increase the volume just a bit. Hello world from the world of bit crushers. Hello world. I'm not distorting, I'm not going over -6. So this is just so that you can hear it without having to increase and lower the volume to hear my voice. Okay, so this is a bit crusher, and it's a kind of distortion, and I'm going to change this slide and you're going to hear the effect it has on the voice. Hello world from the world of bit crushers. 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 Just so you understand how this can simulate a bad phone connection, I'm going to add some EQ. And usually a telephone has a low pass and a high pass. So usually you can only hear things around this area. So yeah, something like this. And then I can remove these other bands. And now this sounds like a convincing telephone. Hello world from the world of bit crushers. Hello world. Think of a bad Skype call. Okay, so now we know what a bit reduction or a bit crusher does. It is a kind of distortion. How does it work, and how can we use JSFX to reproduce this. By the way, this is already a JSFX here in Reaper. It's an effect that comes with Reaper, and it's written in JSFX. So if we wanted to look at how this is built, we can easily do that by hitting Edit. And this is too scary for now. This is just too much. So I'm not going to dive into how this one works because it's doing a lot besides just bit crushing. But it is just so you know that you can always have this option. You can always jump into the code for a JS effect. Okay, now how do we create our own JS effect? I'm going to remove this from the chain and I'm going to add a new one. Come down here to JS. And then right click. Yeah, okay, right. So here I am right clicking on JSFX, create new JS effect, and I'm going to call this my bit crusher. And you can just leave it like that, or you can give it the JSFX extension. I'm going to do that. I prefer to do it this way. Okay, so I just created a new JS effect. It doesn't do much, but it's there. It's a new effect. And now I can click on Edit, like I showed you before. I can click on Edit, and this window comes up, and this is where we are going to actually write the code for our plugin. This is the interface for our plugin. Okay, so this is some boilerplate code that comes with a default plugin when you create it, and it has some parts that we don't care about. I'm just going to remove them. The only part that we care about for now is this. So in JSFX, there are these blocks of code. Different blocks have different intentions and they run at different times. So we only care about the block at sample that runs. So this code is going to run on every sample. Okay, hang on. What is a sample? How does a bit crusher work? What is happening here? Okay, let's backtrack. Let's look at this audio really closely. I'm going to move this window somewhere else so we can look at this audio up close. Okay, zoom in the waveform. Let's zoom in, make it big. Let's zoom in some more and zoom in some more and zoom in. And now you can see that what looked like a blob is actually a wave. And yeah, okay, we know that. Sound is a wave and it travels through air. What's going on in this view? Well, from left to right, that's your time. From before to after, from the past to the future. When I play, the playhead goes from left to right. Pressures. And up and down is more or less, you can think of it as the position of your speakers at that point in time. So when the cursor is right here, that's the position that your speaker cone is at that moment. So this line here, this straight line in the middle, is just pure silence. The speaker is perfectly still. It's not moving, so there is no pressure, no wave pressure coming to your ears. You don't hear anything. And then the speaker, you can think of the speaker like right here, and then the cone is here, and this is time. So the cone is going in and then going out, and then the cone is just moving. And this line is describing the movement of the cone of the speakers, or in my case, the headphones. And when it's doing that, it's moving air. And those waves of pressure of air, sometimes compressed because the speaker is moving towards you, and sometimes decompressed because the speaker is moving away from you, that is sound. That's what we hear. So this line is describing the movements that the cone of the speaker needs to make in order to reproduce my voice. So let's, that's represented as a wave. Okay, that's a wave in the air, a wave of pressure in the air. But if we look more closely, we can see these dots. And now we are very close. We are talking about 1/44,000 of a second here. We are talking about very short periods, some milliseconds, microseconds. I'm not even sure. It's very short, the amount of time that we are looking at here in this display. But what is happening here is that each one of these dots is a measurement. Sound travels through air in the physical space as a wave, but we don't represent it as a wave in the computer. In the computer, what we do is you sample that sound wave every so often. In the case of my project, we sampled that 44.1 thousand times per second. So there are 44.1 thousand of these dots here in 1 second of audio. Each measurement is the position of the cone of the speaker at that moment, where it should be at that moment. And then from one point to the next, the speaker is just going to move and do what it needs to do to get there to the next point. The important thing to remember here is that each one of these are called samples, and they are sampling the sound as the sound occurs in the environment. And in the case of a speaker, it is reproducing the sound, and it's going to make this line, this moving line happen by moving the air. And the code that we are going to write is going to run, so this block of code is going to run for each one of these points, each one of them. You can imagine that this is a lot. It's 44.1 thousand times per second that this code is going to run. So it better be fast. If it's not fast, we are going to hear glitches in the audio. We are going to hear that our code is not fast enough, which is awesome feedback. I'm used to writing code for web applications, and being able to hear some feedback from the code that I write, I think, is one of the motivations for me to want to learn digital signal processing. It's a lot of fun to be able to hear the results. So yeah, we are going to write some code that is going to run for each one of these samples, and it's going to do the bit crushing. Let's look at the interface for writing JS effects, and then we are going to talk about how the bit crusher is implemented, and then we are going to write the code to implement it. Okay, so let's look at this interface. It's very simple. It's an IDE of sorts for writing JS effects, and it's going to run real time. So we are going to write some code here, and we are going to play the audio. And even if the audio is playing, we can change the code and save, and it's going to change the effect it has on the audio in real time. So it looks kind of outdated, but it's super powerful, and it's awesome that we have this right in the digital audio workstation. And it's not only for fun, it's actually something that you can use in real projects. So it's super powerful. I really like this. I'm liking a lot. Though I'm new to this, I'm liking it a lot. Okay, so what do we have here? We have some area in, well, first of all, here on the top, we have the name of our effect, where we can find it in the file system. So we can make this longer, and you can see exactly where that file is in the file system. If for some reason, if you want to go with some other text editor, you know where to find this file. And then here we have a text editor. It's super simple. Most things that you would expect from a text editor are not here. Things like search and replace. I couldn't find a feature for search and replace. But for very simple things, it is good enough. So you can do things like, and here on the bottom, you can see some of the commands. So you can do things like splitting. So you have two panes to work with. Sometimes you want to have some definition of a function here, and then lower here, you want to use that function. Just you have the code that is defining and using something together on the screen. You can also do some simple search and replace, some simple search, not replace, as far as I know. So you can do find, so you can hit Command or Control if you're on Windows and find. So that works. For instance, I searched for Sam and I found Sam, and I can search for next occurrences of that using Command G. And then there is match, and I don't think I understand what match does. Who knows? But there is save. Save is important because, for one, you're saving work, but more importantly, every time you save, it recompiles this code and runs the new version of the code in your audio coming in, so you can hear the effects right away. And then there is peak for Command P for peak, and that is super important. So let's say I'm using some, we are going to look into what this is real soon, but let's say we are looking at this variable, and then we can peek that variable and we can look at the value of that variable. And that is happening in real time. So if we run the audio, hello world, from the... You know what? I'm going to run this with that mute on the master, so you don't have to hear that. We can just look at the effect. But yeah, so now we are running the effect and we are picking the value of sample 0. Okay, that one is not updating in real time, so who knows? Maybe that one doesn't work. Oh yeah, now it's working in real time. I just had to save. So every time I'm peaking, I am getting a different value on the bottom because the audio is actually running, so I'm getting different samples. So that is super important. To peak is super important. Another thing that is important is not listed here on the bottom. Just so you know, the rest of this column here, you're looking at the line and the character. So you're looking at line 3 at 3, that's where my cursor is. There are 3 lines total. My cursor is on the 3rd line, not the 2nd and the 1st. This is where my cursor is on the column. And I am in insert mode. I don't know what other modes there are. I don't think that this is like Vim, where there is insert mode and normal mode. And I think this star means that this is not saved. So if I save, yes, that star goes away. So that's this window. Then there is this window here on the right, and I'll talk about it really soon, but there is one extra command that is not listed here, and it should be because it's awesome. It's not listed here on these menus as well, but it should be because it's awesome. It's F1. So on the Mac, I have to hit command, and I have to hit function and then F1. But when I hit F1, it opens the documentation for JSFX, and that's on the Reaper website. Now for this, it's kind of boring, but if I'm using something like floor, which is a function that works on numbers, and I hit F1, it's going to take me directly to the documentation for that function, which is super helpful. And yeah, so F1, lifesaver, remember that. I don't think you can customize this. It has to be F1. Remember that. Super helpful. Okay, let's talk about the window here on the right. So if you're working with JSFX in some other text editor and you changed something, so you have an option here to open in external editor, and by default it will open here in text edit. So if you change something about this, then you should come back here and do a full compile reset, just so it does what it would do here if you saved it. It recompiles. And if you're running some kind of code that is remembering previous states, then a full compile reset will empty the state. It will start fresh, which is beneficial in many cases. And then in this window, you can see all the variables that exist in the system. So these are variables that are defined by Reaper, and they come by default. So some of them are like the beat position, and that's where my cursor is. So if I change my cursor, this updates automatically. So I can change here to somewhere else. And if your effect has anything to do with the tempo of the song, then you have access to that information. And you also have here the number of times this variable has been referenced in your code. So for instance, beat position has not been referenced. Well, what if I reference it? Now it has been referenced once. Super helpful. So when you are, I don't know, maybe you have a variable and you're changing its name and you want to see how many references you have to remember to change because there is no search and replace. So super helpful thing to have here. And also, if you have variables of your own, and to declare a variable in JSFX, you don't even have to do any declaration proper, you just have to use it. So if you say something like my variable equals the number 3 and save, then you can see the value of your variable in real time. So even if you're on every sample you are changing this variable, you will see this in real time without having to refresh, because there is auto refresh enabled here. If you want to disable this, then you would have to click here. And you can also filter for things like my variable. And I guess you can also filter for functions, things like floor. No, it doesn't work. Okay. Oh, another thing. Yeah, speaking of functions, when you have things like floor, I said that you can use F1 to go to the documentation. You can also peek, Command K for peeking, and then it gives you a short description of what the function is. And if the window is not wide enough, then the description just is truncated. I don't know what a workaround this. I guess you would have to just hit F1 and go to the website. Okay, so let me show you what happens when my variable changes every second or every sample. So yeah, remember that this is running on every sample. Variables don't have to be declared. Initially, they are 0. So initially, variables are the number 0. When on every sample I increment it, then you're going to see this number increasing 44.1 thousand times per second, because that's how many times we are running this code. And we can see that in real time. And all variables are doubles. They are double precision floating points. So you can do this sort of thing because the maximum number that you can store is really large. We are talking about 64-bit numbers. So even this kind of trick of counting the number of samples is safe, I think. I don't know, I'm new to this. You have to take everything I say with a grain of salt. But anyway, okay, so that's the basics of working in JSFX. If you want to alter the samples, as we are going to do, there are some special variables here that have to do with the samples themselves. So SPL0 is the sample in channel 0. So Reaper has a multi-channel system. So you could have a track with 64 channels. So you can think of one channel as mono, 2 channels as stereo, 5.1 as surround system. You can have one track with 64 channels. That's a lot of channels. So you have here the sample in channel 0, in this variable, the sample in channels 1 and 2 and 3 and 4 and 5 and 6, and usually that is what you care about, surround sound. But then you can have a lot more samples. We are working with mono audio, so we are working with this sample here that is mono. So we are only going to look at sample 0. So if I want to look at sample 0, let me play the audio again on loop. And okay, let's make it like this. So I'll look at sample 0 and save, and now you can see that the sample 0 is coming through here. We can see the value changing, and sample 1 is changing as well. That's just because when reproducing the audio, Reaper takes this mono audio and plays it on both speakers. So I have the master volume down and you won't be able to hear this. But when I increase this, I'm not wearing my headphones so I don't hear it, but you should be hearing the sound of my voice coming through both speakers. From the world of bit crushers. Hello world from the world of bit crushers. Okay, so both values are coming in. So you can read these values, but you can also write to these values. So here's a trick. If I write the number 0, then it's going to mute the left side. Let's do this again. From the world of bit crushers. Hello world from the world. Only on the right. So these variables, sample 0 to sample 63, are all the channels that you are working with. I'm in this video only working with 2 channels, but you could work with more. And you can read these variables. You can also write to these variables. As you may have noticed, the values are always between -1 and 1. And let me stop the playhead here. So -1 represents the bottom. It represents the speaker going the most it can in one direction. 0 represents the speaker cone just still stopped. And then 1 represents the maximum it can go in the other direction. So this number for samples is always between 0 and it's always between -1 and 1, in which 0 represents silence, -1 and 1 represent the extremes of what you can do with the speaker. Okay, so that is the basics of what we want to do. We want to look at the sample and we want to change it to introduce the distortion effect. But how do we do that? Now we need to understand how a bit crusher works. Let's draw some waves here to understand what a bit crusher does, how it distorts the sound. So we have our sound wave in the air, and we have some samples, as we saw, 44.1 thousand samples per second. But one thing we didn't talk about is something called the resolution of these samples, because the computer cannot store values continuously like this. It has to approximate. So the computer cannot store all the points that could occur between these 2 points here, for instance. It cannot store and recreate all the points here in between. So what it does is it has a grid. And in this grid, it's going to look at the point and approximate it. So it's going to put just going to store that this point happened in this area of the grid. And it's going to store the idea that this point here happened in this area, in this section of the grid. So we are looking at squares here because in this direction we have the time and we have a box around the points cutting through time, 44.1 thousand of those boxes per second. But also we have a box in the grid. So we don't have actually points, we just have these squares. And that's how the computer actually stores the audio, as these squares, as these numbers in the squares, and the numbers are going to be things like 1 and 2 and 3 and 4. So it's just going to store the number. Is it 1 here or is it 3? And that's what the computer actually stores internally. And those are the points we looked at in Reaper before. But what a bit crusher does is just lower this resolution, something also called the bit depth of the audio. So it's going to lower this resolution. It's going to use fewer bits. So here we have 4 different possibilities, which means that it's using 2 bits, right? 4 possibilities is equal to 2 bits. It's 2. Each bit can be 0 or 1, so 2 possibilities. I should highlight this when I'm saying this because, yeah, it's 2 possibilities and it's using 2 bits. But we could lower the resolution and use fewer bits. In this case, I guess I would have to use 1 bit, right? It's the only possibility. So I would have 2 to the power of 1, which means I only have 2 bands. So now I'm not storing whether this box occurred in band number 1 or 2. I'm storing something that looks like this. So in terms of time, I am not lowering the resolution. So these boxes will not expand to this direction. They will only expand up or down. And so what we are doing is effectively we are merging these two and we are merging these two as well. So now the boxes look like this. And you noticed that previously we had this box and that box, but now they look the same. Previously they were different, but now they look the same. So I'm lowering the resolution, and by doing that, I am losing information along the way. To the extreme, this sounds like distortion because I'm now less able to reproduce the original waveform. I lost information along the way, so I have a more crude waveform that sounds distorted. So that's what a bit crusher does, and that's how it achieves distortion, and that's why it's called a digital distortion. It's digital because we're talking about the number of bits that we are used to store each sample, and digital distortion has a certain character to it. It sounds in a particular way. That's what we are going to reproduce. So a sample comes in, and for each time we run the code on the add sample block, then SPL0 is going to be one of these boxes, or actually it's going to be one of these smaller boxes. And what we want to do is to turn that into one of the bigger boxes. In other words, we have a number that may look like 0.1432. I don't know, that's the sample. That's the position of the speaker cone at this point. What we want to do is to just get rid of some of the information and round that. So we are going to lose some of these new ones. Between 1 and 2, for instance, we are just going to remove some of this and end up with something like this. So what we want to do is to just truncate that number that comes in so that it will be downsampled. It will be less precise. It will be one of these bigger boxes. So that's how bit crushing works, and that's what we are going to implement in Reaper. Let's get back to Reaper. Okay, we are back in Reaper. The master is still turned off, and we can start writing our plugin. So what happens is the sample 0 comes in as a value with a lot of digits, and we want to truncate the number of digits to have something that is less precise, and that's what is going to achieve the bit crushing effect. Well, how do we remove? So let's say that the sample 0 is a number like 0.1432, something like that. How do we get rid of these digits? Well, there are different ways to do this, but a simple one is to just we are going to multiply. What we want to do is just get rid of these digits, right? So what we can do is to multiply this to some factor, for instance, 100. What that gives us is something like this, right? That's the result of this operation. And then we can take just the integer part of this, and that gives us something like this. And now we can divide this by the same number we started with. So divided by 100, which is the same number we started with here in this operation, and we got rid of these digits. We kept everything to the left, but we got rid of these digits. And the number of digits that we keep, so in this case, 2 digits, that's how many digits we kept. The number of digits that we are keeping is equal to the number of zeros in our number here. So another way of writing this, 100 is 10 to the second, right? Because 10 times 10 is 100. So now we have here a number that represents the number of bits that we are keeping, or the number of digits that we are keeping. We are keeping this many digits. So we can say things like digits equals to 2. And then we can change this to be the number of digits. Okay, that is getting there. But remember that we are talking about binary numbers. We are talking about numbers whose base are 2, the number 2. So we should change this base to the number 2. And here we are doing this reasoning in decimal. We are doing this reasoning in decimal numbers. So that's why we had 10 here as the base. But if we want to do this in binary, then we should change this to 2. Okay? So that is the logic. What we are going to do is take the sample, multiply it by this, then take the result and floor it, and then take the result and divide by this. And this factor is appearing twice, so I'm going to call it a factor. I don't know if it is a factor mathematically, but that's the name I'm giving it. So that is the reasoning. So the factor is to the digits. Okay, let's move this below. And then we have the number of digits. We have a factor that is 2 to the number of digits. And then we floor it. We multiply, floor, and divide. Okay, and of course, the result of this, we want to assign back to the sample 0. While we're at it, this effect is going to be mono. We want to hear both sides, both speakers, or in my case, since I'm wearing headphones, both headphones to output the same signal. So I'm just going to say that the sample 1 is equal to that as well, so we get something on the right ear. If I left it like this, we would only get signal on the left. It would be distorted, it would be fine, it would work, but only on the left ear. So I'm going to make it this way. So the bit depth, so 2 digits is too low. We talked about 2 digits here on paper, but that's good for examples on paper. In the computer, we want to talk about a lot more digits. So I'll leave it like 8 digits for now, and we see if we get something reasonable. And okay, I'm saving this now, and I'm going to increase the so before I even increase the volume, let's look at the window for the plugin. Right now it doesn't have anything, any controls or anything, but it does have a meter in the input and a meter on the output. So no signal is coming in and no signal is going out. As I play this, you can see some signal coming in and you can see some signal going out. And these numbers are reasonable they are around -18. So that number is reasonable. So we are safe to put our headphones and increase the master volume. Bit Crushers. Hello world from the world of Bit Crushers. Hello world. I hear the distortion and I hear it on both sides, so it's working. I'm going to decrease this number. Hello world from the world of Bit Crushers. Hello world from the world of Bit Crushers. Hello world from the world. Yeah, and I can hear that it gets more distorted as I lower this number. I won't go too low because it will distort too much. We can do that in a second. But before we do it, I want to make this number user controllable. So I want to make this available for the user of the plugin as a slider that they can use. So I will define a slider. It will be the first slider in the interface. And this slider is going to define the variable digits. And I want it to start with a good bit depth. So I'm talking about something like 16 bits. With 16 bits, you probably will not be able to hear any distortion at all. So it's a good place to start the default value as. And then I want the minimum value that the user can define as the number 1. That may be too low. We have to check it. The maximum value is 16, and the step, the user will be able to change this 1 number at a time or 1 digit at a time. And then the name that the user is going to see is bits, because that's usually the lingo that bit crushers use. In fact, since we are doing this, why not rename this to bits? And then we don't need this variable, right? Because we just defined it here. So now we can save this. I'll lower the volume, save this. And even though I am not playing any sound, I'm not playing my sample, I can still make mistakes in the code that would make the bit crusher output some values that could be too loud. Even if there is no sample coming in, I can always write to the values going out. So if I do that, then I would hear something loud. So that's why I'm lowering the volume. Okay, so now I have a slider here. The default value is 16, and I can lower it to 1 and up back to 16, one number at a time. So 16.0, I slide it, it goes to 15, and so on. Okay, so with that, we can run the sample. Okay, so the sample is running here on the background. Yeah, it's there, it's running. Now we can see some healthy signal going out. Let's increase the volume. World of bit crushers. Hello world from the world of bit crushers. Okay, now let's go to 1, and it's in -6. It's loud, but it's reasonable, so we can hear this. Okay, so it's safe for us to play with this. Let me increase the volume. World from the world of bit crushers. Hello 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 world from the world of... Okay, that was loud. But we are distorting fine. That is a fine distortion. It's a fine bit crusher. Let me stop this. Okay, so that's a fine distortion that we have here. What else can we do with this? A couple of things. I said that we would write this in one line of code, so I'm going to inline this factor. I know I just factored it out and then I'm undoing that, but that's because I wanted to have one line. I promised I would deliver this in one line. Here it is. It's a distortion with one line. Another thing is that I don't see in any other bit crusher, but I think it's fun to do, is we have the number of bits as an integer, and every bit crusher that I could find out there does that. It has a number of bits that's an integer. But, and that makes sense when you think about the definition of the bit crusher, right? When you think of how the bit crusher actually works on paper, as we looked at before. But we know that this number is, it can be some number in between integers. It can be any kind of double precision number. So I will show this using the debugger here first. So one way that I find, I don't think I saw this anywhere. I don't know if other people do this or if there's a better way to do this. But one way to work with, if you want to experiment, there is no console you can use, but you can do something like remove me equals to the number of bits, and then you save, and then it appears here. Another way to do this, I guess, would be to select this code and peek. So there is a debug watch variable here, and you can see that, but I will use the variable instead, just because it's right there, it's simple to see. So the number of bits is an integer, and it currently is 16. What if it is 15.5? Well, that's just another number, not a floating point number, but you can multiply by it, you can take its floor, and you can divide by it. Will it have any effect on the audio? Well, let's see. If, remember that floor is taking the integer that is right below the number that we have. So if I can come up with some number here, I made up a sample, okay? So this is a sample I just made up. If I can come up with a number here that is between 15, so 15 gives me this. So that's 7667. And 16 gives me this 15335. So if I can find any number between 15 and 16 that gives me any number as a result between those two numbers I just mentioned, then yeah, this is a different number. So this is going to floor differently. Let's take the floor. Okay, so this is a different number, and as I increase the slider, these are all different numbers, right? So there is no requirement that the number of bits has to be an integer. What if instead of increasing the bits as integers, we increase them as... So why do I care about this in the first place? Let's hear again our sample. I'm going to remove the remove me variable, and let's hear the effect of the bit crusher as I move the slider. Hello world from the world of bit crushers. Hello world from the world of bit crushers. Hello world from the world of bit... The resolution is too low. It seems like there could be more steps in between. That's why I care about this. And this is something that I think is unique to this bit crusher we are building. What if we just had 0.1, or I guess 0.1 being the step? Now I can have any value in between a number and another. Well, in steps of 0.1. But I have more values to work with. I have a higher resolution in the bit crusher. And let's hear what that sounds like. And I guess I didn't change anything about, I will not turn on the master or just play. Yeah, so this didn't change. When I have the minimum value, it's still around -6. So I'm going to bring this up. From the world of bit crushers. Hello world from the world of bit crushers. Hello world from the world of bit crushers. Hello world from the world of bit crushers. Okay, so now the user has a lot more nuance to work with, and they can dial in the amount of distortion that they want much better. And I think this is good enough. You could go lower, something like this. Now you have even more precision, but I don't think that's worth it from a musical perspective. So I think this is good enough. This is already giving you more control over the amount of distortion. If we could hear the steps between 0.1 and the next 0.1 number, then I guess I would increase the resolution here. But I think this is good for now. We are going to leave it here as is. This is our bit crusher. It's a very simple effect, just one line of code, but it allowed us to see how JSFX can be developed in Reaper. And I should mention that JSFX are written in this. First of all, they are JS effects because they are effects, and because they are from Jesus Sonic, which was this old system by the creators of Reaper, and has nothing to do with JavaScript, as I said. But yeah, so JSFX is a way to run code in Reaper with a whole IDE and everything, but the code you're running is taking advantage of the digital audio workstation, so everything that you work with in Reaper, the routing, other effects, real-time effects like we saw here. We were changing the code and seeing the results in real time. All that is available to you. It's a great environment to learn about digital signal processing, as I'm finding. And it's written in this language called EEL2. So the language that we have been writing here with the add sample block and everything, that is in this language called EEL2. And there is documentation on this language, both on the Reaper website, also on the website for the developers of Reaper, which is Cocos, the company. They have a page describing the language and everything you can do with it. It's similar to C and C++ in some ways. It's very low level, but at the same time, there are no weird things from the past like in C and C++. It's much simpler. It's a much smaller language, both in terms of things you have to learn and in terms of things that are built with it. So it's a less popular language as well, but it's a great language. I'm having a lot of fun with it. And in the near future, I'm going to release more videos with these kinds of explorations. Now you know the basics of what the sample is and how to manipulate it in JSFX, and we can move on to more interesting things, other effects, like a delay, and I don't know. We are going to see. I will try to build an equalizer maybe, and a signal generator for generating things like beeps and sound sine waves, and many other things. So if you're interested in this kind of exploration and live coding, just follow along with me, subscribe to the channel so you get notifications when new videos come up. And that's all I have for now. I hope you learned something. I hope you had fun. And I encourage you to go to Reaper. If you don't have it, go download it. It's awesome for working with audio, for working with video, for working with programming. It's just an awesome piece of software, and you can try it for free. It's super cheap after that. So yeah, go ahead, give it a try, and have fun. And thanks for watching. I see you on the next one.